Off we go then. And so I'd just like to start with suggesting that you look carefully at this slide and at the wee icons that you can see with beside the points of the agenda. I think they're quite appropriate. I didn't pick them. They're part of Microsoft PowerPoint's Design Ideas module, which is obviously a little bit smarter than PowerPoint used to be. And it's a machine learning function that came up with these pictures. So somehow interpreting the words of my bullet points and then coming up with appropriate pictures. You can also see the subtitles, which PowerPoint is putting, I think, or hope you can, which PowerPoint is putting onto my PC. And that's another bit of machine learning. So it's all around us. So I'm going to start today by telling you a little bit about the learning process I've gone through in lockdown, then move on to talk about what data science and machine learning actually are. And then the bulk of my talk will be taking us through the machine learning life cycle, types of problems it can help with, getting the data, building the model, a little bit about deploying it, and wrapping up with a few of the challenges that you might find on the way. I'm a project manager by training, so issues are me. My presentation will probably take about 25 minutes. I was going to say that if you'd like to ask questions during the session, please feel free. If you can find a way of doing that, you're welcome, but without me able to see the chat, and I'm just checking my picture here a bit, that's going to be a little bit more difficult. Those of you who've got your video on, if you did actually physically put your hand up like that, I would take an interjection, but that's only going to be 2 or 3 of you. But we should have, given that means we're not like to have a lot of questions, we should have lots of time at the end to talk. So until recently, I was the IT director of an environmental NGO, which collected environmental data from companies. Quite a lot of my technical background was in data warehousing and business intelligence systems. And towards the end of my time in that role, I included the data science team, which was doing a lot of sort of general data analysis, producing data products, and also doing quite a bit of modeling. So I incorporated that team into the department, but I didn't really get very involved in their day-to-day work. So I was really quite interested in this sort of technology. And when the lockdown came along, I found myself living alone, stuck with a computer, the internet, and not a lot else. So this seemed like a good way of spending some free time. I did start out in a fairly technical way, and I made use of Coursera, which is a platform that provides kind of low-level, so first-year kind of level university courses. A lot of technical courses, a lot of computer science, data science, maths, and some more general business courses. And so I did an introduction to the Python programming language, which is one of the main languages that's used with this type of work. And then I went on to do the University of Michigan's Applied Data Science specialization. And I've also been doing some of Google's classes in machine learning with TensorFlow and things. These are quite good courses. They are fairly technical. They're practical. They're also really cheap. I have a subscription to Coursera, I think it was about $300 a year, which gives me access to a lot of their stuff. And it's something I've had my software engineering teams doing for some years. So I've not used it myself. But I'm not a software engineer, and I'm not really doing this to kind of grow up and become a data scientist. By training, I'm a project manager, business systems analyst, and mostly I've been working with not-for-profit organizations trying to get them the technology they need to achieve their missions. So I needed a wider understanding of these kind of things, and what products are out there, how are people using them, how do you implement them? And also, perhaps partly just out of general interest, some idea of the sort of socio-political issues around them, and there are quite a lot. Fortunately, with lockdown, a lot of conferences and talks obviously went online and became quite cheap. So I got Zooming. I went to CogX, which is one of the biggest AI conferences in the world. Last year was run in London. I think 3,000 or 4,000 people. I've listened to talks from the Alan Turing Institute, which is also based here in London, and the Ada Lovelace one too. There's quite a few named after fairly well-known computing heroes, but also companies, people like Amazon, Databricks, all the works. And as well as that, I've been reading blogs, reading books, and generally following my nose. It's quite fun to do if you like learning yourself, and first time I've had a chance to do it in years. I will, at the end of this, have a slide which I can share. I'll share all the slides, which gives you some links to some of these things if anybody would like to follow this path. So moving along, some definitions. I think we hear terms like artificial intelligence, data science, machine learning a lot. A lot of them are used quite imprecisely. So I had a look around and found a few definitions, but the impression I'm really getting is that the term artificial intelligence has really kind of disappeared into a cloud of marketing hype. And today it covers pretty well anything that looks a bit smart. But probably certainly doesn't come anywhere near to fulfilling the original sort of definitions of machines behaving in ways that would be called intelligent if a human was behaving. They are still, all the things we talk about as artificial intelligence are still fairly constrained. They work within quite a narrow, well-defined problem area. And if you look at them a little closely, you can certainly see those constraints. So personally, I'm rather abandoning that term and using terms like data science, machine learning, and good old statistics and data analysis. Data science is a more concrete term, I think. It refers to a multidisciplinary thing where we take statistics, software engineering, a knowledge of the data, of the area that our data comes from, and pull them together to call that whole thing data science. So in many ways, if you've ever used Excel to analyze some data, perhaps drawn a graph to understand it better, you've been doing data science. And it goes from that sort of thing right up to statistics PhDs. But machine learning itself is really quite a specific set of technologies that essentially allow us to find patterns in data, which can then be used to make predictions. If I show a machine learning algorithm 1,000 pictures of animals, it can learn to figure out that the next one I show it is a picture of my cat. This is a rather overused technique that Facebook and the rest are all pretty keen on. So we're using mathematical tools, but also the massive amounts of data that have become available over the last 20 or 30 years, and the incredible increase in computing power. And those things coming together have turned these techniques, I think, from being quite niche to being so mainstream that they're in every PowerPoint application. When you're thinking about technology, it's, I think, always a good idea to start out by thinking about the problem you want to solve. And these are some of the areas where machine learning is really making a big difference now. Like a lot of computing, one thing they all have in common is that at scale, human skills are becoming a bottleneck. So a highly trained consultant can look at a scan and say whether or not the patient has lung disease, say. But those kind of people are difficult to get, they're quite expensive, and they're not always available, particularly if you want to do scanning of a whole population, you know, sort of things like the various cancer scanning things that we do in the UK, and also in places where there are less well-funded systems, health systems. And other things too. Having a translator with you on holiday is not an option, but I'm sure we've all had the experience of using Google Translate to talk to, I don't know, someone in a hotel. And other things that really wouldn't work without machine learning. So one of the examples that really interested me is the way that the national grid is now estimating the amount of the amount of electricity that will be generated by solar panels to allow it to balance the different ways that they generate electricity so that they don't need to use coal or as much gas. So, that's making a real difference in our ability to deal with climate change. So all of these things, I think, are really good examples of problems that machine learning is coming into play with to resolve. At this point, does anyone have any questions? Kevin, I don't know if you can see anything in the chat. No?
Not that particular. Thank you.
Great, thanks. So I'll move on to go through how we build machine learning models. There's, if you like, one way of looking at it is to say that there's a kind of three-stage process where we start with data, and that's all sorts of data, images, text, so not necessarily the structured data that many of us are used to using. Obviously, the structured data, records, readings from instruments or machines or whatever, all of this data can be used within machine learning. We build models to find patterns in that data, and those models are sets of equations which take the data, give some sort of result. So it might be a lot of photos and the result is tags of what's in the photos, or it could be a whole stack of credit card transactions, some of which have been shown to be fraudulent. Data where we know something about the thing we're describing, and we then create a model using that data, which we then use to predict results for other data. So we take our data, we make a model, and then we use the model to predict other data. So to break that down a bit, the data that we use, as I said, can be all sorts of things, and there's a lot of work been done to be better at processing images, at processing sounds and text. And in machine learning, we talk about the features of an object or of a thing that we're describing and a label. The term features just means much the same as the terms we've used in the past, like attributes, fields, columns, just some aspect of a thing that helps us to describe it. When we're talking about pictures, that might be looking at the picture and being able to pick out the eyes or the shape of the jaw, whatever sort of prominent thing we might use to be able to recognize the difference between cats and sheep. With text, obviously, we have words, we have phrases, we have the way the words associate with each other. So all of these things are features of our data, and there's the work that we do is to try and get that all into some nice, tidy sort of form where we can actually use it. Obviously, you do need quite a lot of examples, not necessarily millions or even hundreds of thousands, but certainly thousands, tens of thousands from a lot of practical applications. So the lung disease example that I took that photo from had, I think, 9 or 10,000 examples where where a real consultant had looked at it, diagnosed disease, which then allowed it to predict reasonably accurately from new photos, from new scans. Social media sites have obviously been quite helpful in this regard because images have been tagged. This is a picture of my cat. This is my friend. Facebook have an awful lot of good data to work with. But it also means that if you already have existing data which lends itself to your problem, you are well ahead. I think most companies probably do have some sort of data that they can use. Some people are better off than others. In the UK, with the NHS and its huge data sets of medical records, we're actually in a really good position to apply some of these techniques. Banks, Visa, whatever, but you might like to think about your own organisation, what sort of data you might have and how you might be able to use it. There's also often interesting data in the public domain or which can be collected in some other way. So I think it's also worth thinking about how you can take the data that you currently collected, perhaps change your collection method slightly to be able to better use it in these sorts of applications. When I think about data, I also think it's important to just have a little bit of a thought about the bias in our data. Does your data reflect the world you want the machine to learn about? And it's kind of the old garbage in, garbage out principle. There's no point in trying to get a machine to learn about people in general if your data set only includes, say, men or white people. I was actually quite surprised I found this example this easily. These pictures yesterday are what Google thinks show a person working. They're the top 11 images that Google came up with when I asked it for person working. There's no sign of any manual work, there's no uniform, there's not even a single person of colour in there, which says a great deal. And this can be a bit more subtle than this quite egregious example. There's an interesting case of Amazon creating a machine learning tool to review CVs and the text in CVs and rank potential candidates. It was doing this on the basis of resumes which it had seen submitted in the previous 10 years who had been hired. And of course, being Amazon and these being text CVs, that meant that the data was highly biased towards learning about men. The system learned to disregard women's CVs to the extent of downgrading applicants who had attended women's schools. So, I went to Epsom Girls Grammar School. If I put that on my CV, this thing was learning that the fact that it was called Epsom Girls Grammar School was a point against me. So a great deal of need to be careful. It can be more than just a data problem, but data is a point where it certainly starts. This kind of problem can be addressed by understanding your data and its origins and testing different categories. So making sure that when you're testing your models, you're running them for say different genders, different ages, different ethnicities, and anything about the features that you're using or that you're telling it about to make sure that you are actually reflecting the world you want the machine to learn about, not just the world that the data happens to give you. So once we've got our data, we need to start building our model. One way of thinking about a machine learning model, oh, sorry, actually, I think I will just stop there for a minute and see if there are any other questions. If anyone wants to ask anything, just shout, or anything in the chat, Kevin.
Yeah, there's nothing in the chat, but if people want to unmute themselves, they can do.
Okay, how many people do we have on the call? I think I can see about 10. Yep.
Yeah.
Sorry, it's just 10 seems like a really small group to be doing a formal presentation without having any interaction. But here we go. So a model is a program which has been trained to recognize particular patterns in data. In a sense, it writes itself based on the data we give it and the algorithm we tell it to use. So it's not starting from scratch and coding. It's definitely starting with the data we give it and the algorithm we tell it to use. From those points, it finds patterns. That means that it's domain specific. So if you give it data about, I don't know, cats and sheep, it's never going to even imagine the existence of a dog. They work within the domain that you ask them to work with. And this is why I think, intelligence and learning are kind of nice terms, but they're a bit hypey. Because, if you think about, if I'm learning about things, I will go out and explore, and I'll be able to work out that another four-legged animal that's making a really different noise is a different thing, and I'll probably be able to eventually figure out what it is. I mean, there are things that are becoming better and better at taking new data that's presented to them and working out how to deal with that new data. So this isn't necessarily a truth forever, but I think it is this domain specificity, a difficult word to say, is a truth for now. The process that the machine learning engineer goes through is to choose the algorithm and the data that they would like to use, put the two together, have the model work over the data and find its patterns, and then test it with different data to see how well it works, rinse and repeat, and keep going through that process until it's meeting the goals that you want it to meet, which will be something to do with how well it's doing its predictions, how many incorrect predictions it's making, and depending on the nature of your problem, you'll decide what a good level of accuracy is, a good level of precision, and you'll decide when it's ready to go. There are a lot of standard algorithms which can be taken off the shelf, configured and used with your data. That's really where the courses I've been doing have been aimed at. And I think to understand these, you certainly don't need a PhD, or at least not a PhD in mathematics or computer science or statistics or anything. But you do need a reasonable amount of knowledge. I'm feeling with I have a maths degree. It's very old, and quite a bit of this stuff has moved on, but I think I could probably learn it. So I don't think you need to be super qualified, but you do need a good understanding of your of the area that you're looking at. So if you're into banking, you'll need to understand banking data. If you're doing things to do with lung scans, you will need to be a medic of some sort. So there are standard algorithms, and as I say, you can take those off the shelf. They're tools that can be used by anyone reasonably well trained. But there are also a lot of pre-trained models where companies have put the effort into working out, into doing all this work, and particularly I think in areas like natural language processing, image recognition, speech recognition. So if your problem involves something like translation or understanding language in some way or recognizing people's faces, you're probably not going to try and build it yourself. You're going to go to one of these services. Perhaps not surprisingly, these tools form part of all the major cloud offerings. So Google, Amazon, Microsoft, all have AI platforms as part of their cloud offerings. The computational power required to train these models, to train the thing that lets Google ask you for a picture of a working person, is huge, and the sort of work effort needed to keep maintaining them is pretty big as well. So I think there's a kind of a logic in that. Right, so you go through this process, you get your data, you go through this process of deciding what sort of model you want, what algorithm you want, you train it, you test it, you get it to the point where it's working, and then you want to actually use it. And that might be standalone if you're kind of doing some research or something, but I think for most of us it's likely to be embedded into some sort of application, so into a website, into something in our back office, whatever. And that's the point where data scientists will often have to start working with the more traditional IT department. So as I mentioned earlier, in my old role, I brought these two together for a while. And the reason I wanted to do that was partly because I thought they shared a great deal in common. We had a business intelligence team and we had a data science team, and there was an awful lot of overlap. But they do come from really different places. Data science work, I think, is often seen as quite experimental, and the procedures may be a lot less rigorous. And when we first brought the data science team in, I had to get them into, or my software engineering head had to get them into source code control. So it was that basic. That's unusual, but certainly production processes are not something that they tend to be particularly used to, perhaps. So there's that kind of culture clash thing to get together. But you're also likely to be involved, to be integrating these models into other applications, and so there'll be some other element in your deployment pipeline. I mentioned earlier that there are a lot of tools like this within the sort of Google Cloud, Azure, AWS platforms. They also have tools for bringing them into production, so which does allow you to keep the whole thing together, I think, quite well. And some of them also support deploying them out to your mobile phone or whatever, which equally allows you to keep the whole ecosystem together. And also allows you to do the sorts of things you do with any production application, the monitoring and tracking. And there's a bit of a nuance to this with machine learning that's perhaps less common with other things, but machine learning finds patterns in data and then applies those patterns to new data inputs. But what happens if those patterns change over time? We're predicting the weather for the solar panel example, but the climate starts to change. We're predicting fraudulent transactions, but a new method of fraud emerges. You can imagine with the COVID crisis that a lot of e-commerce recommendation models, which are also machine learning models, were severely challenged as buying patterns changed really rapidly. And this makes it very important to monitor not just the sort of statistical metrics that that have sort of come with it, but also the business outcomes that you're expecting to achieve. So if your recommendation engine was designed and built in order that you cross-sell in order to generate revenue of X, and that starts to drop down, you need to be on top of that very, very rapidly. In the normal course of things, models will need to be retrained with new data fairly regularly. And some models will do that automatically. And I think that's probably quite a good way of building it in so that when new cases come along and they can be validated, they go back into the training, and it's a kind of constant thing. But also you may well want to regularly program to have it happening at some sort of interval or on some sort of event like your revenue drops or something. Or you may actually find you need a more drastic intervention, and then you're back around the life cycle again. So I have actually been talking for rather longer than I thought. I didn't count the first 5 or 10 minutes at the beginning. So my final slide was just to point out some of the challenges. I talked quite a bit earlier about the way human biases may become automated because your data may be biased. And I think that's one that we're just going to see in the newspapers more and more until that really gets sorted. Transparency and explainability are a really massive issue for these things. A model may get to the same answer as a human would, but it almost certainly won't use the same path that a human would use. And sometimes it won't even get to the same conclusion. So being able to explain to yourself, to your customer, to your patient, how you've got that answer is a huge part of not just making sure that these systems work well, but making sure that they're accepted by the people who ultimately benefit from them. And there's a lot of, I think there's a lot of work going on in this area, and it's not an easy problem when a machine might have gone through hundreds, thousands, in fact, potentially billions of steps to come to a conclusion that isn't obvious. It's a big issue. And I think it relates to another sort of acceptance issue, which is around the kind of creepiness factor, where a machine seems to know things that it shouldn't. Or, I know I often find myself wondering if Facebook's been talking to LinkedIn behind my back. And I think sometimes the reason for that is that I'm the same person and I'm doing similar things. And some of my friends on Facebook are friends on or contacts on LinkedIn, and things get worked out. And I'm kind of trusting enough to think it probably isn't just been data sharing, but frankly, I'm not always sure. And that sort of thing does make you really feel a bit uncomfortable about what you're doing with systems that are using these kinds of technologies. There is a huge data protection issue in all of that. If we're learning from personal data, we have to be sure that first of all, that's actually an acceptable use of the data, but also that it's being done in a way that doesn't expose unnecessary or unreasonable data outside the places that it ought to be. There's this huge problem with any sort of statistical technique where, I don't know. There was a time when I worked for a very, very large company, and they did employee surveys, and I was the only woman in IT at my grade. So if I said I didn't like my boss much, it was going to be really obvious who had said that. And that kind of problem can easily sort of find its way out into places you may not want it to. So keeping a very close eye on how you're dealing with that data and where you're making it available and how you're anonymizing it is really important. So that's it from me. As I said at the beginning, I've put a few links into the slides of places I've been and things I've looked at that I've found quite good, if anybody wants to follow up on any of this stuff. That's more than enough talking from me. Please, does anyone have any thoughts and questions? Open your mics.
I had a question.
Hi, Cathryn, Jodie Garrett here.
Hi.
Hello.
It's Caroline here. I don't know. Can you hear me?
I think I've got, can I take Jodie first?
Yeah.
Jodie?
Hi. So Cathryn, just in terms of challenges, I think something that people need to be aware as well is that the process validation, specifically in heavily regulated markets, there is currently no template or no, best practice way for doing it, which is causing those industries to be very reluctant to take up, AI and machine learning kind of routines, which it's got to be overcome sooner or later. But just to make, highlight that point.
Yeah. So there is a lot going on in finance, I think, and I mean, presumably outside of regulated areas.
Yeah.
But,
so I've just come out of a manufacturing environment for healthcare.
Oh, okay.
Yeah, and it'll be the same with pharmaceuticals and those kind of things. And the tendency from those businesses is they like the idea of machine learning. They think that it has its advantages, but as soon as you start talking around process validation, it creates quite an unknown area. Best way to describe it.
And massive liability issues too.
Yeah.
It's Carolyn Morgan. Can I just respond with a bit of an idea on that? I haven't seen it done. I haven't been responsible for it being done in practice. But one suggestion I heard for getting around that was that you use the AI to propose, you know, whether you accept somebody's life insurance business, but there's ultimately a human where the machine's done the donkey work and presents the findings, and then a human validates it.
Mm.
Good point.
Another Carolyn, who I can see, the lady with the glasses. I'm sorry, I can't. Please, you wanted to speak to.
Yes, thank you. So that was really interesting. I had a question in particular with the biases that you were mentioning, the human biases. Is there any work being done in terms of regulation or regulatory bodies around that? And how do you deal with cultural differences in terms of biases?
Well, there are a number of organisations that are looking at kind of principles of fair AI, which include this kind of thing. But I think it's highly unstructured at the moment, and also it tends to be very internationalized, and I think this is enormously problematic. So, you know, if Google produce something, they're expecting it to be used pretty well everywhere, and they don't really, I don't think they really do anything that's culturally specific, which is probably why we see a definition of worker that looks to me more like Silicon Valley than even London. In fact, it doesn't really even look like Silicon Valley, frankly. It's not a huge answer. I don't know if anyone else has anything to add on that. I think one of the most scary parts of, or sort of aspects of that is actually where it goes into sort of into law enforcement, and you know, I think that's an area that's going to end up regulated pretty quickly, because otherwise, you know, because the things that seem to happen with it are horrible. I believe Amazon, Microsoft, and IBM have all withdrawn their facial recognition technologies from US law enforcement in the light of Black Lives Matter, and you can imagine that somebody will be having a good look at that one.
And I imagine data privacy is another big one, because the rules are so different in different parts of the world on that.
Yeah, and it's also about what data is private. I mean, if there's a public photo of me and somebody recognises it, how private is that? And yeah, I agree.
If you've agreed that your photo is out there.
Yeah, but I agreed my photo was out there, but I didn't necessarily agree that you could tag my name onto it.
Yeah. So it sounds like it's still very early days for that kind of handling of data.
I think there's a lot of work being done in Europe at the EU level, which is likely to yield some interesting results, but obviously won't apply everywhere. And in the past, they have tended to set the standard for data protection, so one might hope.
Thank you.
Thank you. Anyone else? Anything else? Well, I hope this has been helpful. I mean, I'm certainly not putting myself up as an expert, but if you have any other questions, I'd be very happy to take them. And I think that, yeah, it sounds like it might be just about it, unless anyone has anything they want to add.
Well, Cathryn, since I was partly the one that twisted you into it, firstly, I think we're all a bit stilted by the feedback and not being able to see each other. So, apologies if that has restrained anybody. I found it really useful, even though I've been to some talks on things like AI. In fact, I think I went to one of the conferences a couple of years ago to see what I could learn. And you have actually made me think, perhaps I need to find out a bit about Python. So, so thank you for inspiring us. And I'd definitely like to get a copy of, particularly the last slide. You know, I may start reading some of those blogs and get hooked.
Yeah, there's a book on there called The Master Algorithm by Pedro Domingo. And I would really recommend that as a good kind of general read, going through various different applications of AI. It's kind of a popular science book, so, you know, very accessible, but gives you a good general understanding of a lot of things.
What's it called?
Am I not sharing my screen anymore? It's called The Master Algorithm, and it's by a bloke called Pedro Domingo.
Thank you.
Yeah, it's on that slide. And I think coming back to the bias, if you think about it, we're seeing exactly this problem played out every day in front of our eyes as everyone around the world tries to work out who's affected by coronavirus and why. So I think I think all of us being aware that even big data sets can have a bias. So, and as you drill down, you realize you don't have representative data covering one area. So, you know, we know that men in older age groups from BAME backgrounds are more affected. But then if you take out those who are in occupations where they're more exposed, like health workers and bus drivers and so on, you then end up with a smaller group. And if you then take out those who've got diabetes, you then end up with a smaller group. So I think even just being aware that an enthusiastic bunch of data scientists ploughing on without any women in the room is dangerous. That in itself is well worth knowing. So I think it's really interesting, Cathryn, and thank you.
Thank you. Kevin, is there somewhere I can put or send the slides? Like if I load them onto WhatsApp or something?
We can either share them there, or I can individually share them to people that registered via the Eventbrite page.
Yeah,
Okay.
we should probably follow up to see the people who had said they hoped to make it and then couldn't. Did they have a technical problem, or was it simply that they had an emergency and would probably like to watch the recording later?
Yeah, that's a good suggestion, Caroline.
Well,
excellent. Well, thank you, Cathryn. Genuinely appreciate this. But yeah, if anybody else, unless anybody else has got any questions, I'll stop the recording and let you all get back to your, I'm sure, very busy diaries.
Thank you, Kevin.
Thank you very much.
Thank you. That was really great.
Thank you, everyone.
Thanks, everyone.
Bye all.